Okay, hello. I want you to imagine if you take your phone out of your pocket and you turn the screen off, how much does that machine actually move? If you're lucky, you might have some buttons on there, you might have some, this is an older version, but actually now they've taken away that home button. It doesn't move at all that much. These are some images. These are some images that some 19th century artists were asked to do, and they were asked to imagine what the 20th century would look like. They couldn't have imagined what a computer chip is or miniaturization, and these images I think are just so fantastically poetic. So, in the top left corner we have maybe the equivalent of a Roomba robot, electric scrubbing, the newfangled barber. The bottom left, a very dangerous looking tool. We have at school in the top right, which is, I think, a pretty decent metaphor for a Kindle or an iPad or something like that, cramming books into children's heads. And then we have something close and a little bit nicer than maybe intensive farming is nowadays. So from an engineer's perspective, it makes sense why things have stopped moving. It makes sense why pushy things and clicky things and smoking spinny things have all been slowly engineered out, and we've replaced them with pixels, we've replaced them with screens and voice commands and things like that. As it's got more efficient, I start to wonder, is there anything that we've lost? What have we lost as we've engineered this movement out? And this represents a car that my mum used to take me and my friends to school in when I was young. It was an old, knackered red Citroen. And we used to sit in the Citroen on a cold day and it wouldn't start. And we called it Betty. We gave it a name because that made sense. And there was this thing, I don't know what it's called in Danish, but in English it's called the choke. Nobody really knew what it did, but you pulled it out and then something would happen. It kind of just helped you think that maybe you might get going. And we'd eventually get going, and we lived on a hill, so we'd all urge Betty to get up the hill. We get onto the motorway, and she was a bit broken, so as we went past trucks, her windows would vibrate anxiously, or so we thought. The designer had no intention of creating these nuances in the movement, but because of the machine maybe starting to fall apart, it allowed us to project our own characteristics. The second story is when I was working as a product designer back in the UK, and we were asked to redesign a neonatal ventilator for premature babies. So we went to Luton Hospital, and we were supposed to really look and work out how do we improve this machine. But what was really interesting for me was to take a step back and to look at this performance of these machines and these beeps, and the nurses who, they told us they didn't really know what the beeps meant, but they kind of knew when something important was happening. And you had these sick babies and these anxious parents. And I thought there was something really interesting in taking a step back and looking at how a machine and the body language of a machine, how it starts to stimulate our imaginations and play performance. So I was studying my master's at Konstfack in Sweden, and I had these ideas in my head, and I wanted to think about how do we look at objects as something that has a body language. And I started with silly putty, which is the orange thing on the left, and I also I was playing and fidgeting with a slinky. And I had this urge to start making some machines, some expressive machines. I didn't want to make anything that was overly complicated. I just wanted, and I didn't have a function in mind. I just wanted, it was almost like I was making puppets, but with an industrial designer's mindset. And these things here are, I eventually 3D printed them, and they were segments that were held together with an elastic band. And there's a little string, which I imagined as some kind of actuator, if you know what a stepper motor is or something similar. I was ignoring technology. I was just pulling this string, but I was telling people, hey, like a stepper motor and technology and stuff. But the result was this. And I had these strings underneath, and I was pulling them, and as people came to play with them, I was reacting and trying to play with the audience or the people at this exhibition at this point. I concluded that the interesting thing about these is the elastic itself, the elastic material. There's something about elastic material which speaks to us in a bodily way. If you blow up a balloon, for example, you know when it's about to burst. You can feel it in your body. Perhaps it has something to do with the fact that we're made of elastic in some kind of way. So I really focused on this. And I started collecting elastic materials. And I started doing playful workshops to try and understand what the heck I was doing on my master's with some other students. And during this particular workshop, we took a balloon here, and we have this pipe, and then somewhere on the end of this pipe is another balloon. And we filled them and created a sealed chamber. When you squeeze one balloon, the other balloon moves. It's kind of easy to explain with science, but there was something incredibly magical about squeezing a balloon over here and this balloon moving. And when you held it and you closed your eyes, it felt like some kind of heartbeat. And it was really simple, and it's something I really wanted to move on with. So the next prototype I made was this. It's a balloon with a pipe hidden inside this box that runs underneath the table. I was stood at the other side of the table. I wrapped the balloon in Lycra, and I wait for people to come and play, and I chat with them, and then I would start to play with them. They didn't know that I had the balloon underneath the table. They thought I was a genius. And it was an accident, but something which was, on reflection, really nice, was that as the Lycra stretched, the hidden red balloon, the colours of that balloon come through the Lycra, and people started talking about an angry squid as it's kind of pulsing and glowing. And those kind of accidents, I think, are worth reflecting on. So I got a little obsessed with this, and I started making chambers, and I got the sewing machine out and adding lamps and different materials. And I will say that once again I was out of shot, blowing down his pipes, going red in the face, or I had friends with syringes and things. Because I knew that this was kind of possible, but I was interested in the material and the form, and I wanted to leave the technology aside just for this moment. Anyway, this obsession soon led to me buying a lot of latex, and I started making, it was liberating because I could start to make my own balloons and my own shapes. And I was fascinated how latex naturally has this kind of skin feeling to it. So I started putting nipples on, or things from udders or folds from other parts of our bodies, and playing them what happens when you both blow air into these shapes and you also suck air out of these shapes. So at this point, I was halfway through my master's. I was enjoying myself, but I was talking to my tutors and saying, I think this is interaction research. And they're going, no, it's not, because they just saw a British guy red in the face blowing down a tube, potentially losing his mind. So I felt like I had to kind of prove it somehow, and I started doing some research, and I discovered this thing called soft robotics. And it's been around for quite some time. And what's really interesting, I mean, Google it and you can find videos that go back a long way. And one thing that comes up a lot is this tentacle. And it's a really amazing object. And it's also incredibly phallic. But no one talks about this. Underneath, we talk about soft robots of these things that can grab things. Or we talk about how it can save people from earthquakes. And this is all well and good, but I think there's still something very, very interesting in the expression of these objects and something that we should really pay attention to. Anyway, this was my soft robot machine that I made. I'm not a hot coder or electronics guy by any means, but I could use the internet and throw these solenoid valves and vacuum pumps together. And I started adding some electronics in there. I added a lamp inside these objects. So this one's made of a balloon, a latex sack around it, and then inside is a lamp. And I wanted to use a lamp because I also wanted to warm these objects to give them that extra dimension of life. And this video is it's not good quality, but I got my machine working at 3 in the morning, and this was my camera phone. I'll try again. Ooh. Thank you. And what's happening there when it wrinkles is that I can suck air out of the outside skin and blow air into the inside, so adding more levels of expression and shape changing and deformation, albeit on a very lo-fi level. So the conclusion was an exhibition that I called Elastic Interactions of the Third Machine Age. I was at art school, and I felt like I needed to give it some kind of pretentious name, and I think I succeeded on that one. But essentially, it was a machine which I was talking about as the director, and I started talking about these objects as part of the machine, also as actors, creating a performance like I talked about in the neonatal ward. And what was really interesting is that the people that came to interact with these, they thought they were interactive. They weren't. I'd programmed in different movements to do different things, but people were projecting onto these things straight away. People would think this one, for example, was dying. When they picked it up, they thought they'd killed it, and they were asking me, how do I bring this thing back to life? Some people thought it was a heart. Other people were convinced it was exactly like a tiny little frog. And there were worse things as well, as you can imagine. So why? What's this all about? Well, I moved to Denmark, and I got a job as a research assistant at the IXD lab at the IT University of Copenhagen. And we started talking about social robots. These aren't robots that are there that we maybe think about as robots. These are robots that are designed to communicate with us, to become companions, to serve human needs beyond those of labor or common notions of work. So we set ourselves a task. We wanted to invert the assumptions of what a robot should look like. Because going back to the last page, if you look at social robots, they're very human-like. They're white and human-like in an abstract way, but they're cute. They're white and grey and plastic, and a lot of them are absolutely fantastic. But we felt like maybe we should start looking at the more bodily materials and the touchy materials and see where we could go. Temper zoo and anthropomorphism. We wanted to try and just take these forms away as far as we could from things with arms and legs or eyes. Inspire reflections on what we assume a social robot is. And we were also very open, these very ambiguous objects. We wanted to encourage a broader understanding of what they could be. If we play with these objects, what could we imagine the applications? We decided to work with the donut shape. And this decision was made quickly. We thought, hey, a donut isn't really around so much in nature. I'm sure if you go under the sea, you can find lots of donuts. But it was a kind of solid engineered start. A little bit of CAD work, and we made a mold and decided to use something called EcoFlex silicon, which is more traditionally used in soft robots. We improved the machine a little bit. And it was also really important for us to try and open this project, or these tools that we were trying to create, out of the lab, out of people that can code, out of the laps of engineers, and to create an interface where we could invite dancers or mime artists or actors to come and help us choreograph this strange donut shape that we weren't quite sure what it was. And the interface we used was something called Max MSP. It's normally used in sound and visuals, and it means that we could create an interface that within 5 minutes we could invite somebody in, teach them how to use it. They could start moving the bars up and down, changing the tempo, and the segments, of which there were 3 segments in this donut to avoid symmetry, they could be individually and in real time moved. So we've at the end of, or maybe in summer this year, we've started to write a little bit about these in the lab. And we have some rough design principles for what we call expressive robotic otherness. Otherness being something other than ourselves, something unrecognizable as an animal or a human. we talk about juxtaposition. So how can we juxtapose organic, expressive behavior with something that you wouldn't really expect to be organic or expressive, something round, something engineered, something firm. We also talk about elasticity as being a really, really important element of connecting with people and creating expressions. And we also talk about robustness. If these things are ever really going to start to become maybe products or machines or companions of the future, we need to make sure that they're robust and that we can handle them. We'll have a few more minutes so we can watch. This is Jacob, a dancer, and this is just a video of him playing around with the donut. And for those of you that are interested, I've brought this donut. It's a little bit hungover at the moment, but it is kind of working in the back if you want to play with it in the break. But this really illustrates the kind of workshops which I think are so inspiring, in that you keep it kind of open and you give somebody something ambiguous and you let them decide what it is themselves. The ideas that came out of it, I mean, as you can see, he's a dancer, so he was already starting to think like, wow, imagine if you make a suit from this. What kind of performances could you do in a theatre? How could this inspire new ways of dancing? Deadpan face, impressive. So I'm gonna wrap up. This project is ongoing and we're learning a lot, but I want to wrap up with some points. And the first one is be critical and demand more from technology that claims to be social. I think if something is cute and telling a funny joke, okay, that's social, but there's so much more to it than that. There's so much more about connection. I think we need to understand antisocial if we really need to understand social. And we need to know that one person's social is another person's antisocial. I also think we need to understand weirdness and strangeness and decide where that level is. I think we should embrace the potential of elastic movement. I believe we should invert assumptions and look for excluded qualities and take the time to reflect on what we're making. And finally, be playful, be creative and be curious, because it was only through doing that we've discovered these interesting materials and what they can do. Thank you.
Thank you, Harvey. I find it very difficult to find a question here. But what I was thinking was that I guess when we look at robots, we will always look for something human. Whether it's a vacuum cleaner or whatever it is, we are trying to put human feelings into it. I find that very, very difficult with these materials. So, but I guess you said you brought your donut.
Yes.
So people can try for themselves out in the hallway.
Yeah.
All right.
Absolutely.
Okay. Thank you very much. Give Harvey a hand.